This is my Myford MG12 cylindrical grinder. I'll show how I put a linear encoder on the Z-axis table of this machine. It's a Renishaw magnetic encoder strip. I've removed the workhead spindle and the tail stock. This will make it easier to lift off the table onto the cart where we provide access to the mounting location for the scale magnetic strip, which is adhesive backed. Here's the Myford grinder with the table removed, and here's where I have the encoder reader head. And here you can see it's right beside the gear, and it has so tight of a clearance right there. So 3-point mounting pad I have right here. One M6 screw that pulls it at the center point of those 3 pads. This one in here, I have the right reader head spacing, and over in here is the table. This is the magnetic strip. It's on the machined ledge where the rack and pinion system is mounted. And to get the right travel for it, about 12 inches, there it comes up to the edge coincidentally, and the clearance was just fine. I'll show in a moment how I mounted and drilled each of the holes positionally. So this is the reader head mounting bracket. I made it from a monolithic piece of 17-4 stainless steel, and it rests on these 3 pads that are 1/4 inch in diameter. And here you can see the kinematic location on these points here, kinematically constrained. There's the relief cutout so that it misses the gear over there. And then I have one socketed cap screw, no, a button head in the center. And right under that, I have this spherical washer. It goes right down there into the counter bore, and just tightening it down on the center is where it pulls down. A single M6 thread, consistent and repeatedly locates this whole bracket right there. So I left it rough machined, put it on the machine, measured with an indicator, figured out how much needed to be taken off, and then machined to the final size, because the gap between the scale magnetic strip and the reader head has to be within 1/10,000th of an inch. The proper location for these small divots was located by the use of a drilling jig I created. Because this whole grinder, flat and V-way, was modeled in CAD software, and then I derived the proper clearances for the strip that derived the clearances and location for where I would put this drilling jig. So I made a drilling jig on here. It rests on 3 points, a button head right there, these 2 locations on the rod, that creates a line and a point, and then in here are the drilled holes of where I want those pads to go. So I located it off the end, right in there. You can see how it's relieved out. I put a small 1-2-3 block with an M6 thread through it. That constrained it along the Z-axis. It can't rotate. This is controlled by this pad there. And then I just used some drill bushings as these holes, and what they left were divots enough that I could press these 1/4 inch balls into for it to locate. So that's how I made the locating system for it without having to machine a big wide area. Only 3 locating pads needed to be placed. The magnetic encoder strip came packaged inside of one of these movie reel-like boxes. Here you can see the adhesive backing. There's the label showing the exact code that was right for my machine, just put into this box. I'll unwrap it, but it has the metal strip as part of it. Here you can see the digital readout and it working. And then just depending upon how hard I come up to this end stop will influence how much it repeats there. Pretty good. And under here is where it's at. So looking under the table, there it's at. There's the reader head we saw earlier. Very close to the magnetic strip. And then there's the one for the in-feed x-axis. It's a traditional glass scale right there. This Ditron display works good enough for me, but I wish I used the same Acron one that I have on the other machines. Like here on the centerless, I really like this one. It's just a little plunge indicator, but it controls the in-feed. But wish I used this one over here, but when I put it on, I didn't know about that company yet. So that's how I hid inside the table the linear encoder, linear scale for the digital readout in a very non-traditional way. The scale was quite cheap. I think it was $70 for the scale, then maybe $300 for the reader head. Here on the back of the Ditron DRO, I spliced on a DB9 connector with the correct pinout. This cable comes down here to where the reader head is at. So I translated the pins. I'll show now the diagram. Here's the pinout that the digital readout expects. I can use any brand or type of linear encoder I want as long as it outputs RS422 format. Then I can adjust the quadrature pin numbers and I can combine other ones. Here's the exact model number of reader head that I'm using. They're made by RLS, Rotary Linear Sensors, which is a subsidiary of Renishaw. It outputs to a little M8 connector right here. Here's the cable that it comes with. And here's some of the other part numbers that I used for the project right here. But one last minute correction is you need to use the tape linear scale that does not have the center mark for the 0 position. The reference position does cause some issues, so you should order one configured without a reference.